Okay, guys. So let's go ahead and get back into the thick of it. I know it's not like the most fun review session ever, but I hope that you guys can like look at this and review it and use this as a good, helpful studying tool and give me feedback if you guys think that this is a good tool, if you guys wish I did more, things like that. So let's see. So we left off on this one. This is one of those slides that like I came over it in the lecture. But you guys do need to be able to draw and label the different steps of replication as well. And the example is on the exam 2 content. So you'll be able to see exactly what you are expected to know. But yeah, so that's a little like key thing to do. I won't do it right now unless you guys really want me to, but the drawing is up on Canvas. And if you have any specific questions about that drawing, you can shoot me a text on Remind, and I'll answer that tonight and tomorrow. Okay, and then this is another little key point is be able to describe what occurs in each step of replication. So like how the different enzymes work together with each other and how they ultimately replicate DNA. Okay. And then again, another little key point is understand and label the structure of DNA's backbone, right? So understand the 5' versus the 3', understand how that looks, the phosphate group, the pentose sugar, right? This is the base here. Understand this. It's in the, this isn't a unique picture. I pulled this straight from the lecture. So look at this and there's more examples in the actual lecture. So this is just kind of like a blank question. Who is credited? I'll change that. Okay, who is credited with the discovery of the structure of DNA? It's kind of a word. It's kind of a, but who has the credit? You guys can type it in the chat. Do whatever you'd like, but give me an idea. You guys remember those two guys? Yep, two guys. That's one. That's one guy. Yep, Watson and Crick. You almost got the spelling. It's C-R-I-C-K. But if you saw it, you'd know it. But yes, Watson and Crick. Those are the ones that those are the two that are credited with the discovery of the structure of DNA, specifically the backbone, but the double helical as well. Okay, move on. Here is another question. This is going to be more chapter 7, but the GC content in prokaryotes is lower than in most eukaryotes. Is this true or false? I hear true. Anybody else want to take a shot at it? Well, unfortunately, this one is false. So, oh, sorry, I missed one. But it is false. The GC content in prokaryotes is higher, keyword higher, than in most eukaryotes. You can see that. So this is that one slide in here. I'll show you guys. It's that one slide in chapter 7 that shows you the differences between here. So the key differences between prokaryote and eukaryotic DNA. So the GC content is higher in prokaryotes than in most eukaryotes. And then another thing is that the DNA methylation, C is methylated rather than A is in eukaryotes. So eukaryotes is C, prokaryotes is A. Okay, and I believe I just gave you the answer to a different question I had embedded in here. I think it's the next question too. See, yep. So with that information I just told you guys, is in prokaryotes is a DNA, I'm gonna say that's fine, is methylated. So is that true or false? What do you guys think? Oops, what did I do? There we go. Good, true. True all across the board, right? So it is true. The other one is the C, right? C is methylated. Okay, so this is another little key point. Be able to compare and contrast eukaryotic versus prokaryotic DNA. Remember, one's circular, one is enveloped into a nucleus, things like that. And then also, I remember this being a Venn diagram on a lab. So go look at that and review that and know it by the heart. Okay, translation is the process of taking DNA to DNA, DNA to RNA, RNA to protein. I have a C, Okay, let's see, if you will. So yes, it is C. Go back to that one. Here you go. It is C. So it is the RNA to protein. Okay. Transcription, right, would be DNA to RNA, while replication is DNA to DNA. Okay. Let's see. Does DNA polymerase work in the 3' to 5' direction? True or false? A hair false. Okay. Anybody else want to back her up or refute that? Sorry, I need water. My allergies are terrible. I only have the one false. You guys are correct. DNA polymerase works in a 5' to 3' direction. And remember, that's in the context of the actual structure, right? It's the 5' carbon to the 3' carbon. And this, think about this in terms of our bilateral helix, right? So 5' to 3' might be this way on one side, but this way on another side. So that means that we are going to have a leading and lagging strand, right? That's why we have those. Okay, moving on. DNA replication is semi-discontinuous, semi-conservative, bidirectional, or all of the above. I hear a D. Okay. I have another D. Edith, do you agree or disagree with it being D? You agree? Okay, perfect. So yes, that is correct. It is D. This one was a little bit of like an easier one for you guys because I want you guys to connect the DNA replication and these three words because they are, you know, it just so happens that sometimes those short answer questions are 3 points and they're looking for three things, and this just might be those three things. I have no idea, but look out for those things. So DNA replication, repeat it to yourself until you know it. Semi-discontinuous, semi-conservative, bidirectional, right? Okay. Moving on. This would be, we want to name the 3 steps of transcription. We can do that now if you want, or you guys can do it on your own. This is a pretty lengthy PowerPoint, so I'm just going to skip it for now, unless you guys tell me otherwise. I'm going to skip. Okay. This is another little key point. Understand the function of RNA, mRNA, and tRNA, what they do, where they're located, things like that. Draw, label, and know the function of each step in translation. Okay. So translation involves what does it involve, right? If we have our tRNA, we have our mRNA, and we have our ribosome, right? So you can start conjuring up that picture of what the drawing and the labeling would look like, right? Okay, moving on to the next question, we have the true or false. Protein synthesis is an anabolic reaction. I don't like how this is formatted. So. There we go. What do you guys think? True or false? Let's see. I have 2 trues. And I will say you are correct. Right? Protein synthesis requires energy. We need to be able to push the mRNA and the tRNA together. We need to have them make love and then push it out, right? Anabolic reactions take energy to produce, right? All right. The trip operon is which one of these? Got 1. All right, I have a C and I have a D. Okay. Make your best guess if you don't know it, because you kind of want to use, you kind of want to test your critical thinking skills too if you don't fully understand the question. And then also ask me questions if they're like poorly worded. Like I'll help you out. But like use your critical thinking skills and see how you would do. So I have a C. Okay. Cool. Alrighty, CDC. Unfortunately, what am I saying? Well, the answer is C. The answer is C. So an inducible operon would be like the lac operon, right? Although tryptophan is found in turkey, the tryptopteron is found in us. When we eat turkey, the tryptophan in the turkey represses that operon, right? And it can't be all of the above, because if you think about it, can an operon be inducible and repressible at the same time, right? So just think about it like that. Let's see. Move on to the next one. And then also the whole idea with this one is to have you guys think about the tripoperon, lac operon, and the P globe, right? That's part of the lab, but still tie it all together. Oops, sorry. True or false? A mutation always changes the phenotype. That'd be true or false? What do you guys think? I have a false. Okay. False. False. False is the answer. So remember, a mutation doesn't always change the phenotype, but it always changes the genotype, right? I switched out those words to try to trip you guys up, but it didn't work. Darn it. All right. So a nonsense mutation. This is where I think there might be a little bit of trouble. It was a long time ago, but let's try it out. A nonsense mutation, what does it do? I have an A. Okay. You guys want something different than that? You got it? Tell me what you guys think. That's what I want. B. Okay, I've got an answer changed to B. Okay. Amanda, do you agree with A or B? B. Okay. And then Edith, did you want to agree or disagree? B. I got an agreement. Okay, yeah, you guys are good. So yes, this results in a non-functional protein. So I'm pretty sure you guys saw this one said a repressible operon, no way, has no change in the amino acid. I thought we were just talking about how it always changes the genotype and completely alters the amino acid sequence. So if you guys are between something, it was probably these two, but it results in a non-functional protein, because what does a nonsense mutation do? Do you guys know that bit of it? What does it specifically do? I remember talking about it a little while ago, and I was talking about how, like, I was saying, like, this makes no sense, right? Yes. So it makes it, when you're starting a race, when you have an mRNA and a tRNA starting a race through this ribosome, and all of a sudden somebody says stop, this makes no sense, this is nonsense, right? So it's the incorrect coding of a stop codon is a nonsense mutation. Okay. All right, let's really quickly before I move on, this is going to be available to you guys. I'll go over some more Wednesday, but for those of you who are in the Monday, Wednesday, it'll unfortunately be after your guys' exam. So if you have any questions, feel free to contact me and I will be as available as possible. But I wanted to see if you guys had any other specific questions that you would like me to answer before I let this take priority, because if I'm having you answer questions that you already know the answers for, or you have an idea about, I would rather have you ask a question that you really need to know, or I can tell you if it's like relative or not, whatever you'd like. So with that in mind, does anybody have any questions, comments, concerns, anything of that matter? Nothing? That's okay. I'll probably end it right at 6. But you guys are doing a great job, and I encourage you guys to look through this a little bit more. We're on slide 31. We just finished that one. But all of these, it's a little bit kind of like out of whack. If you look at the number, it's not necessarily what's in here, but I did give you guys an answer key. And I'll be posting this later tonight. But you guys are free to go. Have a great night, decompress. If you want to look at this later, you can. Also take a look at the quiz 4 outline that I made. If that really helped you, try doing it on your own and using it as kind of like a template. Like, look at what I highlighted and what I went through and what I made my bullets out of, and then go back and try to maybe do it for 6 and 7 and 10. But a lot of this, I want to drive in one last thing before you guys go. A lot of it is going to be down here. So define and give an example of each of the antimicrobial chemotherapy terms, physical disinfectants, and know how each mode of action and how it works. Sorry, no, this is a typo. Know each mode of action and how it works. Memorize each antibiotic, their mode of action, and what type of bacteria they're most useful against. And it's really just a lot of this, right? It's a lot of defining and key terms, I think, is chapter 10. So look through that, be as, comb through it as much as you can. You have the rest of tonight, tomorrow, and then tomorrow morning, or I'm sorry, Wednesday morning, to ask me questions, email Dr. B, whatever you'd like. But yeah, you guys are free to go. You guys did a great job today, and I'll send this out right now, okay? You guys are good. Have a great night, guys. No problem.